All right, kids, today we're going to start into Chapter 7. This is going to be a longer video than normal because it covers a fair amount of material, kind of 2 days worth of stuff. But first, let's talk about some terminology here. So, here you have 3 lines, right? You have 2 lines going kind of roughly in the same direction, C and D. This line A here that cuts through the other 2, it's called the transversal. All right. Now these other lines are not C and D. They're not parallel or anything like that. But you see here, we have these different kinds of angles. So alternate interior angles. Interior would mean in between the 2 lines. Okay. And of course, exterior would be out here. Alternate means on different sides of the transversal. So alternate interior angles would be 4 and 6, 3 and 5. You see that? See, they're in the interior, but alternate means on different sides of the transversal. So alternate exterior angles, hopefully this makes sense. This would be 1 and 8, and what would that be? 2 and 7. Okay. Now corresponding angles are angles that are in the same spot. So you see how angle 1's like in the northwest? That means it corresponds to angle 5 because it's in the northwest quadrant too. So here you have 4 pairs. You have 1 and 5. You have 4 and 7. You see how they're in the same spot? 2 and 6. 3 and 8. Okay, those are all corresponding angles. Now this should be pretty self-explanatory, these next things. Same side interior angles, well that would be of course 4 and 5 and 3 and 6. That's easy. Same side exterior 1 and 7, 2 and 8. Okay, now we haven't used the words parallel yet, so we'll get to that. For each pair of angles, name the transversal and the types of angles. So remember, depending on the diagram, you can have multiple transversals in the same diagram, just so you know. So, here we have what? WZX and ZXY. And you see how we kind of have this Z shape here. You see the Z shape makes alternate interior angles, alternate exterior. These are alternate interior, right? Transversal would be ZX. Okay, so these are the lines. This is the transversal. Okay. Next one, VZW. I accidentally marked that those were congruent. I used the congruency symbol earlier. I shouldn't have really done that. VZW, this one here, because and angle Y. Now, that's going to have this as the transversal, and these will be the lines. And you see how it kind of makes an F shape. These are corresponding angles. Okay. So when you have a Z shape, you're usually dealing with alternate interior, alternate exterior, and F shape is corresponding. Okay, so they're in the same spot. Now, let's see, VWZ and WXY. Well, that's this whole angle. And you see you got the same situation. You got this, these are your lines. This is your transversal. These are still corresponding, but now we're using VX as the transversal. Okay. Hoping this is starting to make a little sense, but this can be tricky sometimes. Let's go down to the bottom diagram. You should try these on your own first, really, and then just pause this for a moment. So ABD, this CDB, I'm hoping you've seen this right away, that's going to be the Z shape. So the transversal is going to be DB. These are alternate interior. The next one says AED. AED is this. And BFC, which is that. This is a little bit harder, but we are talking about these lines, and this is a transversal. So these are alternate exterior. Okay, because this is in between the two lines, so obviously that's not in between. And then this last one, take a look at this. DAE, that's this angle there, and BCF. This causes difficulty sometimes. So if we're using these two lines, these angles would be on the exterior, but you realize that there's no, the angle has to touch the transversal and the lines. These angles are nothing because there is no transversal. You see? I mean, these angles are exterior, but that's it. These would be alternate exterior because you have this transversal. There's no transversal for those. All right. Now, let's start talking about, oof, look at all these new theorems. Lots of stuff here. And don't worry, we're going to shorten a lot of this stuff, okay? And I'm going to prove one of them. I'm not going to prove them all. If two lines are cut by a transversal such that two alternate interior angles are congruent, then the lines are parallel. So in other words, if you had something like this, okay, and that this angle here was congruent to that angle there, those are alternate interior, that means that these two lines here would have to be parallel, okay? These would have to be parallel. We're not going to write out all that. Are you kidding? If alternate interior angles congruent, then parallel lines. How about that? Okay, same thing down here, but if alternate exterior angles congruent, then parallel lines. So, you know, this would have been something like this. If this was congruent to that, those are alternate exterior. Corresponding, that would be the same position, right? So if this was congruent to that, see, all these things give you parallel lines. If corresponding angles congruent, then parallel lines. Now it gets even longer, right? If same side interior angles are sup, so if this was sup to that, if same side interior angles sup, still kind of some writing to do, but it's a lot better than what's over here, than parallel lines. And then of course we're going to do the same thing, you know, with exterior. So, you know, if this was sup to this, if same side exterior angles congruent, oh, sorry, not congruent. If same side exterior angles sup, then parallel lines. And the last one, we don't really do a short version for this. This one doesn't come up nearly as often. If two coplanar lines are perpendicular to a third line, then they are parallel. It's kind of like corresponding angles, right? There's no shortened version for that. We don't really use this too often. And by the way, all the converses work, yes, except the last one. In other words, the converse for like the top one, you know, if parallel lines, then alternate interior angles are congruent. If parallel lines, then alternate exterior angles are congruent. So all the converses work well, but the last one is not applicable. The converse is not applicable. Okay? All right, I'm just going to do a quick proof of the first one, the one up top, to how we get parallel lines. So watch this. So let's say we were given angle 1 congruent to angle 2. I'm going to give you a diagram here. Okay, and we're going to call this 1 and 2. And we have to prove, we're going to call this line A and line B. And you have to prove that A is parallel. So, you know, we use this kind of tall, skinny 11 for parallel. You have to prove that A is parallel to B. I'm just going to kind of talk through this proof a little bit. What we're going to do is we're going to do this proof indirectly. All right? Check this out. To do an indirect proof, we would have to what? Assume, I'm not going to write out this whole thing, just so you know. Assume that A is not parallel to B. Well, if A is not parallel to B, that means they would have to cross at some point, right? So here I'm going to redraw the diagram. There's angle 1, there's angle 2. This is line A, this is line B, but you see now they cross. So if we assume that A is not parallel to B, that means they're going to have to cross at some point, and then along with the transversal, they're going to create this triangle. Well, remember the lesson that we did earlier this week, the video lesson. We learned that the exterior angle of a triangle is equal to the sum of the remote interiors. Well, if the exterior angle is equal to the sum of the remote interiors, that means the exterior angle has to be bigger than either of the remote interiors. So angle 1 would have to be bigger than angle 2. But that contradicts the given that 1 is congruent to 2. Therefore, this assumption here was false, and A must be parallel to B. It's kind of cool. Do that one indirectly. And we could do some proofs for these other theorems as well, but I just don't have time for that, okay? Just wanted to prove that top one for you. So you got a lot of new theorems at your disposal here right away, okay? We're going to do some problems with proofs. We're going to do some problems without proofs. Here's some algebraic stuff, okay? You're asked for M, you know, is M parallel to N? You know, but work with what you know. We know that these are vertical angles, right? So we know that x squared minus 17 equals 5x minus 3. We can do a little bit of solving. I'm going to set this equal to 0, but moving things over. This is a nice, easy quadratic to factor. X minus 7, x plus 2. And if you have x equals negative 2, that's going to make this angle come out to be negative. So that one doesn't make sense. We cross that off. But if we plug in 7, this ends up being 35 minus 3, which is 32. And then if you plug 7 in here, you're going to come up with 148 for this, this angle. So yes, parallel lines as same side interior angles are supplementary. That's what we wanted to try to show. If these are sup, which they ended up being, that's parallel lines. Now here you're given that lines A and B are parallel. Just so you know, we mark those with like arrows. That's kind of our tick marks for parallel lines. Okay? Now, given that lines A and B are parallel, find angle 1. Well, if they're parallel, that means corresponding angles are congruent, so we could set this equal to each other, right? X squared plus 20x equals 4x plus 36. This is another quadratic. You should be able to solve that. You should come up with angle 1 equals 136 degrees. I'm not going to do the solving there for you. Okay? Because I want to focus on the next page. This is a big deal. You'll see this again, I'm sure. Well, I shouldn't say big deal maybe, but a crook problem. Okay, so you see you got these little arrows here. That means that these two lines are parallel. And I've seen people do some different things with this, and I'm just going to put it out there. I'm going to show you how to do this problem. Please follow my guidance, and you're going to be in pretty good shape every time. Guys, how many lines can you draw? It's called a crook problem because you have this like angle in between these two parallel lines. A crook. How many lines can you draw through this vertex here that are parallel to these? And I hope you realize that's just one. There exists just one line that you can draw through that. Now we have to find angle 1. Angle 1 was this entire angle, but what we're going to do is we're going to break that angle up into pieces. We're going to work with what we know. Hey, these are parallel. These are same side interior angles. So if that's 100, that must be 80. These are alternate interior angles. If that's 40, this must be 40. So angle 1 must be 120 degrees. You should try the next one yourself, okay? You have to draw on two things here because you have a double crook, right? Try this one yourself, coming up with angle X. Remember, there only exists one angle that we can draw through these vertices. So all four of these lines are parallel. Now, if this is 90, that means that must be 90. If this whole angle was 120, that must be 30. Hey, we got alternate interior angles here. This must be 30 as well. And remember, this whole angle is given as 80, so that must be 50, which means X is alternate interior. It must be 50 as well. So, you see how things are different with different problems. In number 4, we started from the bottom and just kind of worked our way up. Whereas in number 3, we started at the edges and just worked to the middle. You just work with what you got. Anyway, you'll see quick problems again, I'm sure. Okay, I'm going to do a couple proofs, and then you guys can do there's 2 more on the back side as well. But so I'm going to start with step 2 just to save time. All right. I'm going to mark some stuff. GL is parallel. That's how we mark parallel with arrows. GL is congruent to GT. And then it says ET is congruent to GT. So you know what? I'm going to catch up to my tick marks right away. You see how I got GT twice. So GL is congruent to ET. That's transitive. Okay. We have to show that these top and bottom ones are parallel. I'm probably going to do something with triangles. I can see, hey, if these are parallel, I can get this angle here congruent to that angle there, right? Angle LGT is congruent to angle GTE, and that's something new, right? If parallel lines, alternate interior angles congruent. Okay. We got GT congruent to GT, reflexive, and I think I got triangles now, right? Triangle LGT congruent to, if I say it'll be ETG, and that's by SAS. What can I take from those triangles? Well, I hope you guys see I can take this angle here and that angle there. Angle LTG congruent to angle TGE, CPCTC, but that allows us to get GE parallel to LT if alternate interior angles congruent, then. So look, what we did here is we We use alternate interior angles in both directions. We got alternate interior angles congruent from parallel lines, and then we used a different set of alternate interior angles congruent to get parallel lines. You'll see that that's a somewhat common thing. All right. So let me mark some stuff here. We got K, F, and SA. So my screen will come back in a moment, I think. All right. So we have this parallel to that, and then we have more parallel. So now we use a double arrowhead. Okay. And got some trisection going on as well. So I'm hoping, you know what, we can say HA congruent to RK. Now I know it's also congruent to AR, but I don't need that. Def of tris. So I got this congruent to that. You see, I got different, you got to be careful here. So with these lines here, this line and you know, this line, that's going to give me this congruent to that. You see how these are corresponding angles? Okay. Angle HAS congruent to angle RKF if parallel lines, then corresponding angles congruent. But you know what? I see another set based on the double tick marks. You see, I'll do those in blue. You see, I can get this congruent to that. Those are also in the same position, right? Okay. So I'm going to say angle H congruent to angle KRF, and that's in the same step. But you see now we have triangles, HAS and RKF, and that's by what? ASA. And then we can finish up with SH being congruent to FR, CPCTC. All right. Now on the back side, there's two more proofs. They're numbered 5 and 6. I'm not really sure why they're numbered like that, but no big deal. If you want to, I had 6 steps for this one, and I'm going to post this document to Canvas, of course. And then I had 5 steps for this one. All right. So you can do that on your own.